Good morning, Physics 30. I hope you guys are all doing well. I would like you to please consider the following. Sorry, had to do it. Couldn't help it. Bill Nye reference! All right, so ladies and gentlemen, I had a request for a reference video this morning. Oh, hi, Freya. Freya's here showing off her toy dragon. Yes, what a good dog. Okay, she gets jealous when I film too many videos, and then she has to come into the video too. Okay. So today, ladies and gentlemen, this video is a custom request, a reference video of reviewing the 3 hand rules that we use in Chapter 2 of Forces and Fields. So we got the 3 hand rules. We have, well, obviously first, second, and third. And with each of these hand rules, they are used to determine varying different entities and directions involved with moving charges and the said produced magnetic fields. So keep in mind that your right hand rules, ladies and gentlemen, are for positively charged particles. Left hand rules are for negatively charged particles. Now, I'm not entirely sure if this video is mirror imaging, so watch out for that one. Be careful on that one. So our first hand rule is used for when we are going to be determining the charge moving around a wire as particles are flowing through it. So most electricity is always electrons flowing through a wire, but back in the day they didn't know that. They thought it was protons. So that's called conventional current. So with that you'd use your right, and for electrons we use our left. So with how that works is your thumb for the first hand rule is going to represent the direction that the electrons are moving, and your fingers are going to go in the pointing in the direction where north is going to be pointing of your magnetic field. So if your current is going to be flowing towards you, north is going to be pointing that way on the bottom, and then this way on the top. Okay? So that is your first hand rule. Okay. Yes, Freya, you're a good dog. Yes. Want to come up and say hi? There you go. Good girl. See, Freya's going to say hi. She's a good girl. Good dog. Oh, yes. She's still jealous I'm talking to you guys and not her. So our second hand rule, ladies and gentlemen, is involving solenoids and electromagnets, and how we are going to determine the direction of the electrons are flowing, and yes, good dog, and the direction that the north end of the magnet is going to be. So with your electromagnet, you are going to have a coil of wire wrapped around a metal core, and with a solenoid, you are going to have a hollow tube of wrapped wire. So in this case, we're assuming it's electrons, so we're going to take our left hand, and we are going to wrap our fingers in this direction again. So, oh yes, you brought me a lizard. Good dog. And then we hold your fingers like this. The fingers are going to curl like this, pointing in the direction that the electrons are going to go. Excuse me, I have to throw a toy lizard here. Freya, go get it. Okay. And your thumb is going to represent the north end of the magnet. So if your electrons are curling this way, then your thumb will be pointing towards you, which is going to be the direction of the north end of the magnet. Okay, so if your electrons are curling this way, north is going to be going that way. Okay. So that is the second hand rule. And your third hand rule, ladies and gentlemen, is there's 2 different ways you can do this. Once again, this one you're going to be more likely to use either right or left, because you may have protons for this one, and legitimately protons. So keep that in mind. Right hand for positive charges, left hand for negative charges. And this one is going to determine the force that a charged particle is going to experience when it is going to be moving through a magnetic field. So there's 2 ways you can do this. If we're going to have an electron moving through a magnetic field, you're going to use your left hand, and your thumb is going to represent the direction that the electron is moving. Your fingers are going to represent the direction of the magnetic field, so where north is pointing, so north would be that way. And then your palm is going to represent the direction that the electron is going to be deflected. So if this is where B is going, that is the direction, the initial velocity of my electron, then it means that the electron is going to experience a force that way. So another way you can hold your hand is if you hold your hand like this. So some people find this easier as opposed to thinking about the palm. So your thumb is going to represent the direction that your electron is initially traveling, or your negatively charged particle. Your forefinger is going to represent the direction in which your initial velocity of your, that's the thumb. Thumb's initial velocity. Your finger is the direction of your magnetic field, so where north is for B. And your middle finger here is going to be pointing in the direction of where that force is going to be experienced. Okay, so if your initial velocity is up and the magnetic field is towards you, then your particle is going to experience a force going towards my right. Okay, so if you're going to be dealing with an alpha particle or a proton, you're going to use your right hand. Same principles apply. Initial velocity, direction of your magnetic field, and the direction of the force. Or you can do this, and then you can have same idea, initial velocity of your proton or alpha particle, or ion, any positively charged ion, and this one is your direction of the magnetic field, and then your finger is the direction that the force is going to be experiencing for that charged particle. All right, I hope you guys find this video helpful and that you have excused my dog's photobombing of said video. Good thing she's cute, right? All right, so ladies and gentlemen, we will talk to you later, and have a good rest of your day. No fires, injuries, or explosions.